ruling an infinite void of darkness. The stars are oases of fire in the cold sky of the universe. Everything is fueled by the energy of their hearts, by the cauldrons of the gods of light. They are the creators of all the complexity of the cosmos. And a long time ago, billions of years in the past, one found a place to allow the universe to begin to understand itself, to plant the seed of life and let it flourish. In the depths of the oceans of a primitive world, at some instant in that past, primordial cells were able to harness the energy of their mother star to nurture the chemical reactions of life. Delicate and ephemeral survival machines that stored the power of the sun, that cherished in their hearts the fire of the god of the firmament. The oceans of Earth had just formed a bridge between life and the sun. Cells began to use its light to convert carbon dioxide and water into the nourishment that kept them alive. A process that unleashed all the power of the sun on our world to create the most precious thing in the cosmos, the complexity of life. Over time, primitive algae neutralized the acidity of the oceans and replaced the methane in the atmosphere with oxygen, dissipating the reddish mist of the world and turning Earth into an oasis within the empire of the sun. So that 600 million years ago, that atmosphere allowed complex life to evolve in the oceans, colonize the lifeless lands, and eventually give rise to the world we know. A living world of which we are a part, as a legacy of that history that connects us with our sun.
Nadie sabe exactamente cómo emergió la vida aquí en la Tierra, pero sí sabemos dónde. La química de la vida requiere de unos pocos ingredientes básicos: carbono, oxígeno, nitrógeno, hierro, y una fuente de energía suficientemente poderosa como puede ser la luz del sol o el calor interno del mundo. Pero también necesita un elemento fundamental: agua líquida.
Liquid water is a more complex substance than it seems. Many structures are constantly forming and disappearing in it, weaving a kind of scaffold within which, in a certain way, all biology develops. Each and every species that inhabits our world, in one way or another, requires liquid water to survive. And it is a logical assumption to believe that any living being out there in the universe will also need it.
Al fin y al cabo, las leyes de la naturaleza son universales, y por tanto los principios físicos y químicos en los que se fundamenta la biología aquí en la Tierra deberían aplicarse también en todos los mundos del cosmos. Por eso hablamos del agua líquida como el santo grial de la exploración espacial.
It is impossible to know the probability that, given optimal conditions, life will germinate on a world, but what we do know is that on Earth, that seed flourished as soon as water oceans formed on its surface. It is reasonable to think, then, that there is at least a possibility of a second genesis. That life began on some, perhaps many, of the more than 20 billion Earth-like worlds that inhabit only our galaxy. If we want to find life outside our home, the event with the deepest scientific and spiritual implications in human history, there is only one way: follow the water. Look for lost oceans in the universe. Venture into strange worlds where life might have found a way. Write the Odyssey of the seas of the cosmos. After 166 days of flight through the cold and dark void of space, the Mariner 9 probe reached its destination, a spacecraft destined to decipher the secrets of our sibling, a world that had always fascinated us. A 15-minute and 23-second firing of the main engine successfully placed it in Martian orbit, becoming the first probe to stably orbit another world. The Red Planet, and all the wonders it had hidden for centuries, awaited us. For nearly a year, Mariner 9 orbited Mars, navigating its skies, silently photographing its surface, and creating a map of the world. A map that was like writing a history book. The probe was reading the past of that world. A tale etched on its surface forever. On Mars, there have been no significant erosion phenomena for billions of years. So the scars of events from ancient eras remain open. But what we found in a remote location of the planet evoked a memory we never thought we could find on that desolate world. When examining the southern hemisphere, Mariner 9 found an immense plain stretching over 2,300 kilometers in diameter. A colossal crater over 9 kilometers deep. The footprint of destruction that, at the same time, revealed Mars's past. Around the crater, a large landmass extended, which to the disbelief of scientists examining the Mariner's photographs, seemed to be sculpted by water currents. Across the terrain, named evocatively as Noeki's Terra or Land of Noah, we found valleys and geological formations that only large bodies of water could generate. We had, for the first time in history, found evidence of water beyond our world. It seemed that Mars, now a desolate landscape, was once populated by rivers, lakes, and even oceans. A new era of space exploration had just sprouted. The search for water in the universe was a reality. However, the understandable limitations of Mariner 9 made it impossible to determine the amount of water that might have existed on the red planet. We had come so close. So close that from the day those images arrived, Mars became the top priority of space exploration. We needed a new generation of spacecraft that could be sent to the world to investigate the existence of water and, above all, determine what made it disappear. Unfortunately, for many years, engineering did not progress at the pace of our dreams. The mission required technology that was unreachable at that time. But it was only a matter of time. Of patiently waiting for those dreams to become reality. And finally, those hopes materialized on November 26, 2011, when the MSL probe took off from Cape Canaveral towards the Red Planet. A $2.6 billion mission destined to reveal the nature of our sibling in the solar system. 8 months of travel through an ocean of darkness until the splendor of the Red Planet revealed itself. It was the moment of truth. Years of hopes and fears decided in moments. In the 7 minutes that NASA had dubbed the 7 minutes of terror. The probe entered Mars's atmosphere to culminate the boldest ambition in the history of the space agency, to land a robotic explorer on the surface of the Martian world. Second by second, at a speed where absolutely nothing could go wrong, the probe approached the ground. It stopped at the precise moment to release its sibling. Curiosity emerged from the module, ready for the moment of decision. A few seconds of uncertainty until contact was finally made. Curiosity had touched down. We had completed the landing. The 7 minutes of terror were over. We had completed the most challenging part of the mission. It was time to do what we had dreamed of so many times. Unravel the secrets of the God of War. Curiosity, a mobile laboratory designed to take samples of Martian soil and analyze its composition, had landed in the Gale crater, a plain 154 kilometers in diameter with an age of about 3.6 billion years. A place that, if large bodies of water existed in the past, gathered all the conditions to have been a great Martian lake. Exploring the crater, Curiosity quickly found evidence confirming our hopes and intuitions. The plain was full of polished and rounded stones in a way that only rivers could carve. The robot was perched on what was once a riverbed. There was no doubt anymore. Mars had been a planet with water. But at that moment, we couldn't even dream of what Curiosity was going to reveal shortly. 2 months after landing, scientists found the perfect spot for the robot to begin its main mission. A small sand valley within the crater named Rocknest. Its location, downhill from a group of dark rocks, was ideal for Curiosity, equipped with an arm with a shovel to take soil samples. And the chemical analysis of that fine sand showed something totally unexpected. The Martian soil in that crater contained sulfur, chlorine, and above all, water molecules in quantities we had never imagined. Although Mars seemed like a desolate and dry place, 2% of its soil still consisted of water. Curiosity had just given us everything we needed. Mars past, once a blue planet like our home, had been revealed to us. Long ago, when our world was nothing more than a hell where life could not yet find a place to thrive, Mars was an oasis. The only blue planet in that primitive solar system. 19% of its surface was covered by an ocean as deep as the Mediterranean Sea, protected by an atmosphere very similar to that which inhabits the Earth today. Mars was a water world for hundreds of millions of years. Rain fell, and rivers flowed on its surface, collecting the most precious fluid in the universe in the northern hemisphere, forming a sea that covered a fifth of the planet, populated by waves that, due to its low gravity, rose tens of meters like walls of water over the ocean. Average temperatures hovered around 25 degrees, creating a place we could call home today. These habitable conditions of Mars shaped the so-called Noachian era, the time when that blue planet was favorable for the emergence of life, when it became the king of the solar system. However, its reign did not last long. 3.8 billion years ago, a cataclysm was unleashed in the solar system's empire. Bodies in the inner solar system suffered an asteroid bombardment from the outer regions, known as the Late Heavy Bombardment. Countless icy rocks entered Mars' atmosphere, sowing devastation on a world that was flourishing. During the fierce bombardment, which lasted between 20 and 200 million years, over 50 tons of asteroids fell on every square meter of Mars. More than a third of the planet's surface was destroyed, swept away by messengers from the dark reaches of the solar empire. A prelude to the death awaiting the planet. On the ruins of that chapter of its history, Mars plunged into a cold and arid era. Rivers dried up. The water that had once freely navigated its surface became trapped in colossal ice deposits, frozen in space and time until the depths of the world, as if wanting to fight against that cold, awoke. Mars' volcanoes roared with unprecedented anger, and as magma emanated from the heart of the planet and temperatures in that furnace increased, a sudden thaw of those reserves occurred. All that water was suddenly released, causing floods unlike any in the history of our empire. Furious masses of water, following the path of gravity, flowed from the southern mountainous regions until they encountered a monster. A canyon, 100 kilometers long and 10 kilometers wide, called Ecos Chasma. A precipice that intersected the path of those violent rivers. the most immense waterfall the solar system has ever witnessed was forming. The water cascaded down cliffs over 4 kilometers high, a sight that cannot be compared to anything humans have experienced. A world of water in its full splendor. A sibling that passed on its legacy before plunging into darkness.
Mil millones de años después de esa gran inundación, todos los ríos y mares de Marte habían desaparecido, dejando cicatrices que mostraban las maravillas de ese pasado. No sabemos exactamente qué hizo que Marte se convirtiera en un mundo árido y frío, pero todo apunta a que algo en su corazón estaba empujándolo hacia la muerte.
Earth's magnetic field protects us from the wrath of the sun, from the onslaught of solar winds, a kind of protective shield that originates thousands of kilometers beneath our feet, in the Earth's core. In it, convection currents make molten iron rise, while the Earth's rotation pushes it to spin.
Y como cualquier líquido conductor de la electricidad rotando, genera un campo magnético que en este caso se alza hasta el espacio, desviando las partículas que portan el devastador poder del Sol. E igual que la Tierra, ese primitivo Marte disponía de un campo magnético.
There was a time when, under the splendor of that shield, the northern lights danced over the poles of the world. A shield that safeguarded the integrity of the air and the seas of a world that, at that time, was the treasure of the solar system. However, fate was written from its birth. Formed in a region of the solar system with less rocky material, Mars could not grow as much as Earth did, and that lower mass condemned it from the beginning. Mars's core cooled rapidly. About 3 billion years ago, when its heart stopped, the dynamo went out. The magnetic field vanished instantly. Its protector had abandoned it. It was at the mercy of the wrath of its mother star. The sun bombarded an unprotected world, stripping it of its atmosphere and everything that maintained the balance of that oasis.
Sin protección, expuesto a los vientos solares, los ríos se secaron y los mares se evaporaron, dejando solo recuerdos de su existencia. El que durante tanto tiempo había sido un mundo azul, se había convertido en el planeta rojo que conocemos. La superficie se heló y Marte, de algún modo, quedó congelado en el tiempo.
Mars had always been our hope. The only place where we believed we could search for that trace of water leading us to a second Genesis. But all those hopes rested in the past. We believed that nothing in the present could keep the illusions alive. Until we understood that perhaps dreams were going to lead us to unexpected worlds. In the lands of the Sunshine State, at 4:53 p.m. on that October afternoon in 1989, the space shuttle Atlantis is getting ready to carry a part of us into the sky. Safeguarded within it is a probe that will explore the nature of the king planet. Galileo has begun its journey, a voyage that took it across the inner solar system, through the asteroid belt, and finally, in July 1994, close to Jupiter. The largest of the worlds in the solar system. A giant around which it managed to orbit, ready to witness its splendor. For months, the Galileo probe observed and analyzed the captivating atmosphere of Jupiter, revealing wonders that we were unable to perceive from a distance, including the devastation caused by an asteroid that, by the whims of unavoidable gravity, fell into the clutches of the king of the planets. But what truly marked the mission was when Galileo turned its gaze toward Jupiter's offspring, its moons. Tiny worlds that we were just beginning to appreciate as they deserved. The volcanoes of Io, previously discovered by Voyager 1, appeared as beasts of fire, a hell on a moon orbiting around a gas giant. But it wasn't Io that captured Galileo's attention. Its gaze landed on another of its satellites, Europa, the smallest of its 4 Galilean moons. A moon barely 3,000 kilometers in diameter that we had always considered an icy world. A massive sphere of ice. However, when the probe observed its surface, it quickly detected something. The number of craters on Europa was much lower than on all the other moons it had observed. And knowing that all of them should have received a similar amount of asteroid impacts, there was only one explanation. Europa's ice was constantly renewing itself. Its surface was not static. Something from its depths was nourishing it. They had found indications of a kind of tectonic plates in its thick ice cover. The first sign of such activity on a world other than Earth. And these regeneration evidences suggested something unique. The existence of a liquid water ocean beneath Europa's ice. A sea in its heart responsible for the movement and renewal of its surface. The first proof of the existence of liquid water beyond Earth had come from a tiny moon of Jupiter. Still, temperatures of -163 degrees at its equator and -223 at its poles seemed to shatter all their hopes. Maintaining liquid water in the depths of such a frigid world seems impossible. At least if we relied solely on the warmth of the sun. But there was another force that could heat the moon's interior. Gravity. Europa is a world tormented by the immeasurable power of Jupiter, a giant 320 times more massive than our world. Caught in a gravitational dance with its siblings Io and Ganymede, the gravitational forces on it are constantly altered. Tidal forces keep the fire in its heart. Gravity prevents everything from freezing in time, expanding and contracting with each orbit like a ball hitting a wall. Friction causes the moon's interior to heat up. Jupiter's gravitational torment keeps its heart tempered, allowing a liquid ocean to hide beneath that thick layer of frozen water. Europa's magnetic readings proved that the presence of this internal sea was not only possible, but that the ocean could extend to more than 100 kilometers deep. 10 times deeper than the deepest corner of Earth's seas. And at the bottom of that ocean, in the rocky mantle and in contact with the depths tormented by the tidal forces of its father, there would have to be a collection of hundreds or thousands of hydrothermal vents. Submarine volcanoes releasing the heat from its heart, melting the ice on the outside and making, despite being more than 700 million kilometers from the sun, 5 times farther from the warmth of the mother star than we are, a world of liquid water exist. In total darkness, at a pressure 2,000 times greater than that of Earth's atmosphere. The conditions that made the seed of life germinate on Earth could be repeating. Beneath the ice of a moon around a gas world, we had found the first ocean of the cosmos.
Pese a los hallazgos, al no estar preparada para toparse con algo así, Galileo no pudo identificar la naturaleza del agua en ese océano. Por ello, desde el primer momento quedó claro que teníamos que regresar. Y precisamente en 2024 la NASA tiene previsto enviar a Kepler, una sonda que llegará a Júpiter en abril de 2030 y que estudiará las aguas de Europa, ayudándonos a determinar si en efecto reúne las condiciones óptimas para la vida.
Meanwhile, on September 21st, 2023, it was announced that the James Webb Space Telescope had detected carbon dioxide on Europa's surface, possibly originating from that subterranean ocean, and accumulated in recent geological times. This discovery, of which Kepler will take the lead when it arrives at Europa, albeit cautiously, may provide indications that Europa possesses the right conditions to host life. Similarly, other satellites of Jupiter remain in focus. Although not with the same certainty as Europa, the Galileo probe itself determined that Ganymede, the largest moon in the solar system and the only one with a magnetic field, could also harbor an ocean of liquid water twice as massive as all the seas of Earth combined. Likewise, it found indications that Callisto, in case it contains some type of cryoprotectant, could also have an internal ocean extending to depths of 300 kilometers.
Con los descubrimientos de Galileo en los satélites de Júpiter comenzamos a comprender que las lunas podían ser las mejores candidatas en la búsqueda de agua, pero lo que verdaderamente lo cambió todo fue lo que encontramos años después en otro lugar, en las cercanías del mundo de los anillos.
On December 25, 2004, after a 7-year journey through the solar system, a perfectly orchestrated symphony of gravitational assists, the Cassini probe reached its destination. One of the greatest feats in the history of space engineering had completed its journey to the realm of the rings. It had entered orbit around Saturn, and immediately it set its sights on its first target. An enigmatic world whose nature had always been hidden beneath an orange-hued twilight. Titan, Saturn's largest moon, was the only satellite in the solar system with a dense atmosphere, a place we had always wanted to explore. And there was only one way to do it: venture into its depths. On that Christmas Day, Cassini released the Huygens probe, named in honor of the discoverer of that moon. The machine, in free fall toward Titan, plunged into the interior of the world. Its goal: to conquer the farthest ground that had ever been a part of us. Plunging through the dense atmosphere at over 19,000 kilometers per hour, enduring scorching temperatures, the probe was delving into uncharted terrain. And after completing its descent maneuver, while its parachutes opened, it revealed a moon much more complex than we had ever dreamed. We were receiving images of the surface of a world orbiting a planet 1 billion kilometers away. And upon landing, it took an unprecedented photograph. Huygens was seeing what appeared to be a riverbed. Rocks that looked as if they had been polished, eroded, and rounded by a moving liquid. The probe's findings were an absolute surprise. No one expected to find that on a moon whose surface temperature was minus 180 degrees. It was clear that whatever that liquid was, it couldn't be water. Something unknown was roaming Titan's surface. Continuing its mission, Huygens detected significantly high amounts of methane, a substance that on Earth behaves like a flammable gas. But in that icy world with high atmospheric pressure, it could behave very differently. Methane could exist as a liquid. Titan might have rivers, lakes, and even seas and oceans not of water but of methane freely flowing through the world. Unfortunately, Huygens, stranded in a dry expanse of Titan and surviving only for a few hours, could not find any trace of that liquid methane. There was only one hope: that its mother, from the skies, would finish what it had started. A year after landing in orbit around Saturn, Cassini flew over Titan again. It was time to search for the Holy Grail on that moon. And sailing over its north pole, it saw something strange through the mist. Something in the world was shining. And it could only be one thing: that sea that Huygens had intuited. Cassini had just found what would be dubbed the Kraken Mare, the first extraterrestrial ocean discovered. The first time in the history of space exploration that we had found stable bodies of surface liquid in the universe. Titan had a whole collection of large lakes, a frigid twin of Earth. The most Earth-like place we have found. Illuminated by the light of a sun 100 times weaker than the one that shines on Earth, methane on the moon cannot remain in its gaseous state. It precipitates from the atmosphere, falling in the form of rain onto the surface of the world, creating river systems that flowed into the great seas of Titan. oceans of liquid methane. In this landscape at the same time, we found evidence of organic chemistry. Atmospheric methane reacted with sunlight to create carbon compounds, the fundamental building blocks of life. We discovered traces of hydrogen cyanide molecules, the pillars of amino acids, as well as acrylonitrils, compounds with the potential to form cell membranes. We had found an oasis in the shadow of Saturn's rings.
Todos los ingredientes, todos los elementos de la química de la vida parecían estar presentes en Titán. Las únicas dudas evidentes eran si la vida podía prosperar a esas temperaturas tan bajas y, sobre todo, si unos mares de metano podían ser la cuna de un génesis. Pero solo había una forma de saberlo: sumergirnos de forma literal en los océanos de ese mundo.
Following the promising findings of Cassini, in 2009, NASA proposed the development of the Titan Mare Explorer mission, an unprecedented project in the exploration of the worlds of the solar system. The agency's goal was to send a submarine to Titan, a spacecraft that would carry out the first nautical exploration in an extraterrestrial sea, analyzing the methane oceans, the moon's seabed, and the maritime shores. Recent observations of storms on the moon provided evidence that methane-generating processes existed somewhere in the world. If these processes originated from cryovolcanoes or hydrothermal vents in the depths of the seas, all dreams of Titan's habitability became more significant. The submarine explorer would provide the answers we needed. However, despite being one of the 3 finalists in the project competition in 2012, indications of the presence of high amounts of nitrogen in the seas that would make the maneuverability of the submarine nearly impossible led the US Senate to reject the mission. If it had gone ahead, the launch would have taken place in 2016, and the Explorer would have arrived at Titan this year in 2023. Nevertheless, another project has come to fruition. In 2017, the Dragonfly mission was selected as the 4th mission within the New Frontiers program. NASA will send a lander with a robotic drone to Titan, which will fly over the world to study prebiotic chemistry and the habitability of Saturn's moon.
La fecha de lanzamiento prevista para Dragonfly es 2027, llegando a Titán 7 años después. Con este helicóptero lunar esperamos escribir un nuevo capítulo en la historia de la astrobiología, pero Titán no es el único hijo de Saturno que mantiene vivas las esperanzas. Existe otro oasis oceánico alrededor del mundo de los anillos.
On the outer edge of the rings, a tiny world sails with a diameter of only 500 kilometers, as small as to fit within the borders of Spain. The most reflective object in the solar system, Enceladus, the icy moon. Long considered a satellite covered by a perfectly smooth layer of ice responsible for reflecting more than 90% of the light that strikes it, we thought it was a dead moon. But when, in April 2017, very close to the end of its life, Cassini observed it up close, we saw that we were very wrong. What seemed to be a compliment to all the years of Saturn exploration turned out to be one of the great discoveries, arguably the greatest, of space exploration in the 21st century. As Cassini approached Enceladus, something strange emerged from the ice. Columns of water vapor were rising from the moon's surface, like roaring geysers, erupting from the depths of the world into the emptiness of space. It was an unprecedented discovery. Nothing in the history of astronomy could compare to it. More than 200 kilograms of material were emanating from Enceladus every second, feeding one of the outer rings of a Saturn that, like a cosmic vacuum cleaner, was engulfing its moon. It was clear what we had to do. The discoveries pushed us to take very high risks, forcing Cassini to do something for which it was not prepared. Piloted from more than 1 billion kilometers away, the probe was dangerously guided close to the moon. Cassini ventured to just 48 kilometers above the surface of Enceladus. It had to dive into those columns, allow a piece of us to touch the water of a tiny moon. As it flew over the moon's surface, it revealed that the geysers emanated not only from one region, but from 4 large fractures in the ice. Each of them was 130 kilometers long, 3 kilometers wide, and with a depth of 500 meters. Water vapor was emerging from these abysses. Cassini approached these water and ice cryovolcanoes so closely that with a series of flybys, it managed to touch them, analyze their composition, and what it found left scientists breathless. The ice in the columns consisted of frozen particles of salty water. We were navigating around a tiny world hiding an underground ocean of salty water, like an earthly sea beneath the ice of a Saturnian moon. So far from the sun, Enceladus was guarding a liquid water ocean thanks to the colossal tidal forces tormenting it. The moon follows an elliptical orbit around Saturn, implying that the gravity it experiences constantly changes in the day and a half it takes to complete one orbit. During this time, it is also under the influence of one of its sisters, the 4th largest of the 83 moons of the gas giant. Dione keeps Enceladus in orbit but simultaneously exerts a powerful gravitational pull on it. The ice moon, tormented by ever-changing gravitational forces, is a victim of internal friction that heats its core, causing the ice to melt. This allows the existence of the hidden ocean that had only hinted at its wonders. When the ice columns were analyzed in more detail, we found complex organic compounds and silica particles that could only come from one place: hydrothermal vents on the ocean floor. Cassini's measurements showed that in the depths of Enceladus's ocean, the world had to be active. We had found much more than a lost sea. We had found an oasis in the icy distances of the solar empire.
Estamos bastante seguros de que en los océanos de Encélado existen unas fuentes hidrotermales que aquí en la Tierra fueron la cuna de la vida. Tenemos agua caliente en contacto con hielo y minerales, gases reactivos e incluso un hidrógeno molecular que fue uno de los alimentos de los primeros seres vivos en nuestro mundo. Encélado tiene a priori todos los ingredientes. No es ninguna locura decir que existe una posibilidad real de que hoy haya vida alrededor de Saturno.
The prospect of life forms inhabiting Enceladus's moon is exciting, but we have to be cautious. If it exists, given the conditions, it would be the simplest life we can imagine. Microscopic beings, primitive life forms adapted to that hidden ocean. In July 2021, a new study that re-examined the vast amount of data from Cassini's flybys found evidence of large amounts of methane also emerging from the depths. These abundances could not be explained solely by geological processes. The methane from Enceladus either came from primordial organic matter being broken down in the seas, or from processes that science does not yet understand. The hypothesis that microorganisms generate this methane is, again, a possibility, but one that we have to be cautious about. We know that Enceladus is a moon gravitationally tormented by its father and one of its siblings, a moon with a violent past, so variable that perhaps its interior ocean has only just emerged. On a cosmic scale, it might be something new. We cannot know for how long Enceladus has contained this ocean, but if it has only existed for tens or even a few million years, it probably hasn't been enough time for life to find a way.
Si algún día encontramos vida en Encélado, además de las propias consecuencias del que sería el descubrimiento más importante de la historia de la humanidad, tendríamos algo fundamental, un indicio de que la vida germina siempre que se reúnen las condiciones. Si por el contrario confirmamos que no hay nada vivo en los océanos de Encélado, tendríamos el indicio de que la aparición de la vida es más complicada de lo que pensábamos. Y ambas alternativas, si lo pensamos, tienen unas implicaciones muy profundas.
But in one way or another, what we found on the moons of our empire pushed us to follow the trail of water beyond, to initiate a new era of space exploration, to search for oceans beyond our realm. seas illuminated by the light of other stars. "150 million kilometers from Earth, the Kepler Space Observatory is patrolling the deepest corners of the Milky Way in search of evidence of exoplanets. A hunter of worlds beyond the solar system, hoping to find a place similar to our home. Among the more than 150,000 stars it observed, one in particular caught the attention of the entire community. A faint red dwarf 124 light-years away experienced a very slight decrease in its brightness, a sign of a planetary transit. A world was orbiting its mother star. It had hunted another exoplanet, adding to the list of 2,600 it had already discovered. But this one had something unique, different from all others. The planet, named K2-18b, orbited in the habitable zone of its sun in a 33-day orbit, meaning that, being a red dwarf, the world was receiving a similar amount of light as we get from the sun. The existence of liquid water was possible. With 8 Earth masses, K2 was in a size range between Earth and Neptune, a planetary class known as mini-Neptunes, a type of world that, despite not existing in our solar system, is one of the most common throughout the universe. In-depth transit analysis revealed that, despite being 8 times more massive, it was only 2.5 times larger than Earth. K2 was denser than a gaseous world, but less than a rocky planet like our home. At the same time, the density was enough to maintain a thick atmosphere that, if it existed, could make the existence of oceans of liquid water possible. Kepler's findings were promising enough for the most renowned telescope in modern astronomy to turn its gaze toward this world. The Hubble Space Telescope joined the exploration of K2-18b, hoping to find what everyone dreamed of. The telescope examined the light of its mother star as it transited, inspecting the spectrum of the planet's atmosphere when illuminated. Finally, in 2019, the spectroscopy results were revealed. Hubble had captured what seemed to be a faint trace of water vapor. For the first time in history, we had found evidence of water outside the solar system. The first exoplanet where we detected the Holy Grail of cosmology. It was possible that K2-18b was inhabited by vast oceans of liquid water.
Las mediciones de vapor de agua en la atmósfera se encontraban en un rango muy amplio, en algún lugar entre el 0,01% y el 50%. Al fin y al cabo estamos hablando de un mundo a más de 100 años luz de distancia. Pero en cualquier caso lo que está claro es que no es cero, e incluso tomando el rango más bajo, este sigue coincidiendo con el perfil de un planeta con océanos de agua en su superficie.
The nature of K2-18b is still surrounded by much controversy and speculation. There is a possibility that it is more like Neptune, a gaseous planet. But it is equally likely to be a rocky world, a place very much like what we might call home. A place filled with clouds where rain falls into immense oceans that have conquered the planet. A world partially or entirely covered by water. An oasis more than 100 light-years away. To this day, it remains the smallest planet whose atmosphere we have been able to analyze, finding that everything we can study, its orbit, mass, density, and gaseous composition, corresponds to what is expected in a water world.
Sabiendo que K2-18b era un mini-Neptuno, quizás el tipo de planeta más frecuente en el cosmos, y viendo su potencial habitabilidad, llegamos a la lógica deducción de que debía existir todo un subgrupo de mini-Neptunos que, como él, podían albergar vida. Los astrónomos bautizaron este tipo de mundos como planetas hiceánicos.
The concept was born in August 2021, thanks to a team of exoplanet researchers from the University of Cambridge, who defined Hycean planets as worlds composed of a habitable ocean of liquid water, surrounded by an atmosphere rich in hydrogen. Presumably common around red dwarfs, they would be the best and most promising places to look for life in the universe. Hycean planets are immense water worlds that can be 10 times more massive than Earth and composed of over 90% water, hosting colossal oceans that extend hundreds or thousands of kilometers into the depths of the world. Toward a place without a rock bed, but an unknown territory where water would condense into exotic forms of ice that do not exist on Earth. The extremely dense hydrogen atmospheres trap the heat from the star, creating scorching conditions on their surface. However, it's the high pressures that keep the water in a liquid state despite reaching temperatures as high as 200 degrees Celsius. Their oceans don't evaporate under the weight of the skies, maintaining a stable and conducive environment for life in their depths. Thanks to these protective atmospheres, the habitable zone for oceanic planets would be much broader than for rocky planets, a dynamic range that would allow for the existence of liquid water, as close as 0.01 astronomical units in the case of small red dwarfs, and as far as 12 astronomical units in stars similar to the Sun. Worlds very close to their star could be tidally locked, with one side constantly exposed to the heat of their sun, and the other perpetually in darkness. In contrast, those dwelling in the outskirts of their stellar system, despite living in the frigid regions of their empire where very little light reaches them, their skies and internal heat would maintain the pressures and temperatures necessary for water to continue existing, providing time for life to find a place beneath the peace of their seas.
Las teorías acerca de los planetas hiceánicos avivaron el interés por K218b, haciendo que James Webb echara su mirada hacia esa nana roja y su hijo. Los resultados fueron publicados en septiembre de este mismo año. El telescopio no solo halló evidencias de la existencia de un océano superficial de agua líquida por la presencia de dióxido de carbono y metano sin amoníaco, sino indicios de un biomarcador. James Webb había encontrado dimetilsulfuro, un compuesto que aquí en la Tierra está estrechamente ligado a la vida.
Astronomers have called for caution and prudence. The existence of this biomarker still needs to be confirmed. But whether we find the answer on this world or not, we have arrived at the place we were looking for. The trail of water has led us on the right path. All we have to do is keep observing the stars. Dive into the oceans of the universe to find what we have always been searching for: hope.